Hi all, welcome back to today's session. So in this session we will be dealing with module 5, and in module 5 we will be dealing with least square formulation and also matrix factorization methods. And coming to the first session, I will be dealing with least square problem formulation. And before coming to the formulation, we'll just see the need for what we use the least square method. So if you're given a system where Ax is equal to b, and suppose this is a system of equation, and if this system of linear equation, it is having more equations than the unknowns. Suppose we have 2x plus 3y is equal to 5, and say x plus y is equal to 7, then we'll be able to solve this. Since we are having two equations and two variables, we'll be able to solve this. But when there comes another independent equation, say 7x plus 3x plus 7y is equal to 21, let it be, and in this case we are having three equations and two variables, and mainly in this case we see that the solution do not exist. Okay, when we are having three equations just in two variables, we say that the solution need not exist. Okay, or we say that the system of solution does not have an exact solution. And since it does not have an exact solution, even though we'll just try to find a random curve which tries to fit this values, okay, which tries to fit this equation. We'll just find xy such that xy approximately satisfies one curve. Okay, this system of equations. So for that we use the least square method. Okay, the least square method is used to find an approximate solution that best fits the given data. So the problem will be clear when we have the uh, sorry the section will be clear when we do more problems. So now coming to the theory part, if suppose you are given with the m by n matrix, say A, and if suppose you are given with the B, which is a component of Rm, then the least square problem is to find a vector x belongs to Rn which minimizes the squared Euclidean norm of the residual, that is usually we'll be having to solve Ax is equal to b. Okay, now what we do is we'll just take x minus b and we'll take its norm. Okay, we'll define what is the norm in the question in the problem session. So we'll need to minimize this norm. So we'll just take the minimum value of x for which this norm is having the minimum value. Okay, so that particular x will be called, the value will be called the solution. We'll just see how we do the problems. So now let's go to so in this session you will be basically having questions only to formulate the least square problem. Okay, so let's see one problem. So in this, three measurements are given: 1 2 2 2 and 3 4. A straight line of the form y is equal to ax plus b is to be fitted to the above data using the least square method. So we are asked to construct the matrix A and vector B according to the linear model. Then we'll have to formulate the least square problem in the matrix form. That's it. Okay. So you are given with the data. So what you do is we'll just apply these points to the given equation. We are given with y is equal to ax plus b. So which is our first point? It's 1 comma 2, which implies y is equal to 2 when x is 1. Is it? So a plus b. We have one equation, and coming to the next equation, that is 2 2. So y value is 2 and x value is also 2, so this will be 2a plus b. And next one is 3 4. So the y value is 4, so 4 is equal to 3a plus b. Now we have three equations where 2 is equal to a plus b, 2 is equal to 2b plus b, 4 is equal to 3a plus b. Now using this equation, what we can do is we can just convert this equation, this particular three equations, to the matrix form. So what we do is we'll just write the a b here, and what happens in the first section, we have 1 1, so that is 1 into a plus 1 into b, that is equal to 2 2 4. Okay, so in the second we'll have 2 1 3 1. We'll just formulate this in matrix form. Okay, that's what is given in here. Okay, this is the way where we formulate the given data in the matrix form. Hope you got it. We will be given with the xi and the yi values. Just substitute in the given line with given curve. Okay, if it's a line, just substitute it in the line. If it's a parabola, substitute in the parabola. Okay, and we have the equation, then formulate it into the matrix form. Now in the least square method, what we do is we'll need to get the norm of ax minus b, is it? So for that, what we square of norm of ax minus b. So we'll see how we'll get the value. So to get the norm, what we basically do is we'll just do, this is your a, this is your x, this is your b. Now we'll take this b to the LHS and it will be of the form this way. Okay, now we need to need to get the minimum value of x, right? Your x was equal to ab, so minimum of ab, norm of x minus b. So your a is this, x is this, b is this. Now just do what happens. Okay, before that let me explain what is this norm. So this, if suppose you are given norm of, you'll have to take 2 comma 5 square, 2 norm. Okay, by 2 norm what you mean is root of 2 square plus 5 square, and since you are taking the square here, this will be 2 square plus 5 square. Okay, so basically that will be 4 plus 25 and you'll have the answer. So that is the definition of this norm. By this norm we mean we'll be taking the squares and then adding each and every entries. So by since you are having ax plus b, what we do here is we'll just multiply them, and then we have, what is the first row? First row would be a plus b minus 2, right? The first one is a plus b minus 2 is the first entry, so the square of that, plus the second one is 2 into a plus b minus 2 the whole square, plus 3 into a plus b minus 4 the whole square. Okay, this is the way we form the norm, we get the norm. And to get the least square formulation, what we do is we'll take the minimum of a and b, the minimum of a and b for which this equation is satisfied. That particular a will choose that particular a and b, and for that value we'll just do ax plus b. Okay, we'll substitute for a, we'll just find that a and b and then substitute y is equal to x plus b, then you will be getting a line. That line will be the best fit curve to the given data. Okay, so basically what you'll have to do is just arrange the data, get formulate it in the matrix form ax equal to b, then do the norm ax minus b the norm square. Okay, then you have this particular equation. This is how you formulate least square problem. Now let's do another problem. So 3 experimental observations are given here. It's not 3, in fact it's 4, right? A quadratic curve of the form y is equal to ax square plus bx plus c is to be fitted to the data using the least square method. So what we do, we are given with x and y, we'll just form the equations first. Okay, so here you give the x values to be 1, so first one will be a plus b plus c is equal to y value is 1, so you have this equation. And for the second one you have x value is equal to 2, so you have a 2 square is 4, so 4a plus 2b plus c is equal to your y value is 4 equal to 4. Okay, in similar way form the equations using the other two values also. So you have this equations, and now convert it in the matrix. Your matrix will be, first entry will be 1 1 1, then the second row will be 4 2 1 9 3 1, and it would be 16 4 1, is it? Yeah, this is your matrix, and your x will be a b c and your b will be equal to 1 4 9 16 correspondingly. And now we can do, find the norm square. Okay, you'll just take ax minus b, and now what you do is a plus b plus c minus 1 the whole square, that is your first term. And you have 4a plus 2b plus c minus 4 the whole square is your second term. And your third term is 9a plus 3b plus c minus 9 the whole square. And you have 16a plus 4b plus c minus 16 the whole square. You will have to choose the minimum of a b c. Okay, so this is your formulation of least square for the given problem. Now we'll just do one more problem. Yeah, here you have the cubic curve. Okay, you're given with 5 points also, and you are asked to write the system of equations corresponding to the data. We need to make it in the matrix form and then formulate the least square problem in the scalar form. So you have the given data, you will be arranging it in a similar way. Just apply the points x. Here the x value is 0, y value is 1. Here the x value is 1, y value is 2. Here the x value is 2, y value is 5. Just arrange it in the matrix form. Okay, and you have this v. And now what you can do is you need to get the norm of ax minus b. For that, in the first one it will be 0 into a plus 0 into b plus 0 into c plus d minus 1 the whole square, which is d minus 1 the whole square basically, right? You have the first term. Similarly, you can multiply the first row and get all the entries. Okay, so this will be our answer. This is the way you formulate the least square problem. And now